So let me discuss about the conversion of the following IP addresses to binary numbers. So first one, the 201.17.29.4. So I just add here. Since we have already the speeds 128, let me put 64, the 32, 16, 8, 4, 2, 1. 1 plus 1, 2, 2 plus 2, 4, 4 plus 4, 8, 8 plus 8, 16, 16 plus 16, 32, 32 plus 32, 64, 64 plus 64, 128. Okay. So let's start with the, let's start with the 201. So I'll be using this in notepad. I'll be using this notepad to show how I am calculating the binary. Okay, so so let's start at 201. So 201, we have to deduct the 128. This one, 128. So let me get the calculator. And let me share my calculator so that it would be clear to how I get the or how did I convert the IP address to binary. So as I have mentioned earlier, okay, this 201, you have to deduct or subtract the 128 from 201. So 201, meaning it can be subtracted. So let's just finish this one. So, okay. Meaning, let's put here. Okay. Meaning we have one here. So 1. And then what's next? So 73. It's just 73 minus 64, which is here. So meaning it can be deducted as well. So 64. So we will place again 1 here. And then we will continue with our subtraction, which is 9. The next number would be 32, so it cannot be. So we have to put 0 on it. Okay, so then the 16. So 16 cannot be subtracted from 9. So again, we have to put 0 on it. Okay, and that's here. Okay, and then 16. What else? So 9, yes, can be, or 8. So yes. So the next one would be 1. And then for 2, it would be 0, 0 because 1 cannot be subtracted from 4 and 2. So 0, 0. So 1 can be subtracted to 1. So we will put here 1. So the first, for the 201, the first binary would be 1100, 1001. So let's move on to the second one, which is the 17. This one, 17. So 17, it cannot be, obviously you cannot subtract 128 from 17, so it would be 0. So 17, 6, and then 64 as well. So we will put 0 again, another 0. let me just put no space there, it should be. So 64, then again 17 to 32, no, cannot be as well. And then 17, yes, 16 can be subtracted from the 17. So we will 17, so we'll put 1 here. And then, so meaning we have 1 left from it. So 8 cannot be subtracted to 1, so 0. Again 0 for the 4, and 0 for the 2, and then 1 minus 1, so can be, so 1. Okay, so the second binary for the the 17 would be, the binary numbers of the 17 is 0, 0, 0, 1, 0, 0, 0, 1. So let's move to 29. So 29, 128 cannot be subtracted from 29, so let's put 0. And then again 64 cannot be subtracted from 29, so 0 again. Then as well as 32, then 29, let's put it here. Okay, so 29, 1, 2, 3. So 29, well, we'll deduct 16 from 29. Okay, so would be 13. So that's meaning we have to put 1 here. And then 8, 13 minus 8. So meaning another 1 here. And then 8, so 5 minus 4. So another 1 here. And then 0, and then 1. Okay, so let's proceed with the 4. Let's convert the number 4 from our IP address. So if 4, of course, 128 cannot be subtracted from 4. So 0, as well as 64, 32, 16, and 8. But 4 can be subtracted, so it means 1, and then 0, 0. So this is our binary numbers of our IP address, the 201.17.29.4. Okay, so I'll just move it here. I'll move it here. Put space here. Space. Okay. Then so problem B, we will do the same process by converting it to binary numbers. So let's start with 192. Again, 1, 1 to 8 again. Let me just copy the other numbers. Let's see. Okay. Okay. So let me start with the 192. Okay, so then again, we have to subtract the 128 from 192. So here we go. 1, 2, 8. So meaning it can be. Okay, so we have to put 1 here. Then 64, since the difference is, the remaining is 64. So the 64 minus 64, yeah, it can be. So 1, and then the rest will be 0, 0. Sorry, 164 for 32, for 16, for 8, for 4, for 2, for 1. Okay. And then for 168, of course, it can be, so 168 minus, again, our 128, meaning, okay, again, 1, but then 40 cannot, 64 cannot be subtracted from 40, so let's put 0 here, and then 32, 40 minus 32, so can be, so let's put 1 here, and then 16 cannot be, then what's our remaining number? 8, so 8, 1 here, then the rest would be 0, 0, 0. So 4, 2, 1. 1, 0, 1, 0, 1. Let me again. It's 168. So 168 minus 128. Let me review. 168 minus 128, meaning 1, then 0, then 32 can be subtracted to from 40, sorry. 32 from 40. So meaning 10. No, 1, 42, 0, then 32. Sorry, I'm confused now. Okay, 1 for 28, 68, 10, 64. Cannot be 32, can be, so there's 8. So it should be, for 16 should be 0. For the 48 should be 1, and the rest will be 4, 2, 1. So 1, 0, 1, 0, 1, 0, 1, 0, 1, 0, 0, 0. Okay. And then again, of course, for our 1 should be 0, 0, of course, because 128, we cannot subtract 128 from 1. So should be 0. For 64, for 32, for 16, for 8, for 4, for 2, and then 1. Again, the same. 128, 64, 32, 16, 8, 4, 2, 1. So this is our binary numbers for this IP address. Let me again do the same. Let's put it together. B. Okay. So let's move to our C problem. Okay. Again, same process. Excuse me. So, okay, let's copy again our. I forgot how do we call this. Okay, then. So we have 172 that we have to subtract again as I have told you, the same process. So the 172 has to be deducted. Has to be deducted by 1, 2, 8. 172, 128. Okay. So meaning 1, but the difference is 44. So of course we cannot deduct 64 from 44. So we'll put 0. And then 32 can be deducted from 44. So let's deduct 32 from 44. Okay, and then we have 12. Okay, so and then we have to put here 1 again. And then 12 cannot be deducted from 16. I mean, so 16 cannot be deducted from 12. So 0, 128, 1, 64, 0, 32, 1, 16, 0. Okay. And then 8. So 12. We'll deduct 8 from 12. Okay. And we have to put 1 here. And then, so 8 and 4. Then 2, 1, 0, 0. Is it 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Impossible. Okay. I'll put it here. Okay. Meaning 0, 0, 0, 0, 0. All 0. Because this is 0, all 0. So I have to put 8 zeros. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. 1, 2, 1, 2, 3, 4. 1, 2, 3, 4. Okay then. So we finished already the problem C. So let's proceed with the number 2, which is to convert the binary numbers to decimal number. So I will just do the show you. I'm gonna use this one. I don't know if I can get. I have to use some. Okay. And then they should be. This should be to 2 raised to the. Yeah. And then let me put like this. So since we will times this one, just will put like this. Okay, 2 to the raised to the 0 power. This one is 2 raised to the power of 1. Okay. 2 again. Then 2 should be 0. 1, 2 again. We'll put here. This should be 3. This should be 4. This should be raised to the 5, power 5. Then 2, 6, 6, and 7. So we have already here. Get my calculator. The other calculator, or I'll check if I could just, So we will be concentrating only we will, this one we will not include because it's 0 times 0, it will be 0. So here only, we will get this one only, 1. This 1 times 2 to the power of 7. 1 times 2 to the power of 6. I believe with us. Let me check for convert 1 to okay. Let me check if I could get this. Yeah. So 2 times 2 times, it's gonna show here. Let's get the scientific one. Okay. Scientific, which is 1 times 2. So should be, I don't know how to use this. 1 times 2. Okay. 1 times 2 equals 2. Okay, so raised to 7. 128. Okay, 128. 128 plus, again, repeat the process. So 1 times 2 to the 6 to the power of 6, 64. So put 64 here, plus, since this is 0 and 0, so we'll just ignore this. So 2. Okay. In terms of 2 to the third power, 2 to the 3 power of 3, so 8. Plus 3 to 2. Okay. See this one is this one, this one, this one. Ignore the 0. So 1 times 2 to the power of 3 is 8. 1 times 2 to the power of 2 is 4. Then here it should be 2 fours. And then this 1 times 2 to the power of 0 is 1. So now we have to calculate it. It's 4 plus 8 plus 6 plus 8 plus 4 plus 2 plus 7. Let me double check. 128 plus 64 plus 8 plus 4 plus 0 plus 1. 207. 2, 3, 4, 5, 6, 7, 8, 0, 1, 1. Times 2, times 2, times 2, times 2, times 2, times 2. Yeah. 2, 3, 4, 5, 6, 7. Yeah. What is it? 0. 1, 2, 3. X. So 0, 1, 2, 3, 4, 5, 6, 7. So ignore, 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 ignore. So let's focus then here. So 4 plus 2 plus 1. My God. 2 to the set to the sorry, 2 to 2 is 4. Okay. 2. So it's plus equals to 4, 6, 7. And let's into the next one. Since this is, we have to ignore this one, I will just focus here in this 0. So let me just focus it here, which is the power of 1. This 0, this is 0. Just okay. So this is 2. This is let me just okay. Then this is this is 4. I don't know, maybe I will overlap here. So in the third, where is it? 1, 2. So 3. 0, 1, 2, so 3, 4. Okay. So let's again. Again. We will let's copy it here. Is there any 4 here? No. Okay. 2 to the 4th power. Is it 16? Just that's where's my calculator? I don't have a calculator, did I? Let me sharpen my calculator. Okay. So we have 2 to the power of 4. Okay, so 16. Okay, I'm correct. But I should do that. I do have a calculator and the one, but I don't know where did I put that. Anyway, so let's proceed with starting 3 here. 1, 2, 3. Anyway, let's just do this. 2 to the 3. Three plus 1 times 2, 2. 4, 16, 8, 10, 26. 8, 10, 26. Okay, so we have 2, 7, 7, 26. Again, let's focus in 0, 1, 2, 3, 4. So 5, 5, 3, 6, 7. So times 2 to the power of 7. So let's delete the zeros. Okay. 1, 2, 8 plus 5. Yes. It's just there. 32 equals to 10, go 1, 60, 60. Am I correct? 6, 160. So 160, right? 1 to 8 plus 3 to June 160. That's correct. Okay, once it's 160. So 207. 207. I don't know if it's correct. So 7, 26, but 160. 1, 2, 160, 26, 7, and 207. What is the network address in binary? Okay, let's proceed. Let's proceed now with the problem 3, which is, okay, the network address was given, the subnet also, and so what is the network address in binary? So I actually have calculated it, so you have to calculate it again by, what is the network address in binary? Again, you have to do the calculation. 192.168.11. Did I? Yeah, here. 192, it's been 192.168.11. 192.168.11. So this is the, we'll just copy this one. It looks like me, that's why I do remember that. So open rates not automatically. Yeah, it's not automatically. Even here. Okay, let's just put it there. Or do I have to make it difficult for me? So the subnet for this is 255.255.255. I have to do the same process with the binary. So I have actually calculated already. So I have here, so 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Since 2, 5, 2, 5, 2, 5. Okay, then 255, 255, 255, then 0, 0, 1, 2, 3, 4, 5, 6, 7, 8. Okay, this is the binary. And this is 24. How do I write 24 again? Like this. The prefix, yeah, prefix length is 24. Then in the network address, I need to underline the network portion and circle the host portion. Can I annotate? Yeah, annotate. Can I can annotate. Okay. So the host would be in this network. Underline the network portion and encircle the host. Okay, so sorry, it's underline and encircle the host. So I will just encircle the host, which is this. Okay, and then let's, where's our underline? Oh, for a while. It's okay now. Let's just close this one. Okay, so and then here I'm gonna underline it here. Okay, so this one is the network, network portion, and this is, or the net, yeah, the network, and then this is the host. Okay, so since we finished already here, so we will proceed with the next questions that need to be answered. Oh, let me, because it's, see, oh my G. How can I? Oh, no, it's not like the annotate is, we need to erase because it also ran with our, okay, so let's just, of course not. I just, you know, I will just, highlight this one. Okay, I cannot just, anyway, this is, so here we go. And then I highlighted that it's not, I know that you are asking us to encircle, but I don't have actually the, as I have told you, I am using a Zoom meeting to record my laboratory. So I tried to use the annotation, but it also ran, when yeah, so I cannot really, let me check here. There is really, let me again, I think it have to be saved. Okay, let's check if it's not moving. Yeah, it's still moving. It's still moving. So I don't know how to, so let me just put it that way. I just highlighted it. I cannot circle it. Let's proceed with the questions here. Okay, so I actually researched already about that earlier. So I'm gonna just, I'm gonna plot it. This one is that. And this one is, why do we need to convert? Okay, since the IP address, why do we need to convert decimal value to binary? Since the IP address is a decimal in nature. It is decimal in nature. Or I will put on, since the IP address is decimal in nature, which we can easily understand in nature, in which human can easily understand that the thing is, the computer cannot, but the computer cannot. So that is why we need to, that is why we need to convert it to binary, binary numbers. Correct. Let me rephrase it. So, since the hypothesis is decimal in nature, in which human can easily understand, if we want to relate here, if we want to relate the human and computer interaction, interaction interactions, so it needs, to be converted to a number or a number system that the computer can easily understand. That a computer can easily understand. Okay. Can easily understand, and that is the binary numbers. So why all computing devices have an IP address is possible? Is it possible? Let me put them sometime here. So is it possible that to have some agent and devices? Since I have already I have already researched for this. I did write already the answers. So hold on, I'm gonna put it. So I open devices have the IP address. It means oops. So the internet IP is one of the protocols. Let me write it. Second one, is it possible to have cellular? Oh, cannot, because a conflict, of course, when two or more devices in the same network are assigned the same IP address. So conflict, of course, will occur when two or more devices in the same network are assigned the same IP address. So if this happens, the network becomes confused by the duplicate IP address and can't use them correctly. What is the importance of subnet? What's the importance of subnet? So the subnet is this one. So this is the main purpose. So the main purpose of subnet, what is important? When entered when entered to IP settings into IP settings, what device it is to enable it to determine what IP addresses should be considered local to it, and so can be discovered and communicated with directly, and which IP addresses should be considered remote. Remote and laptop. Okay. Okay. So what can we conclude this activity? We can conclude that yeah, it's a better number to complete the should be completed along with but understandable by humans. This called okay. In this exercise, it is very important to know the conversion of decimal, mid-binary decimal, or even converting the octal and hexadecimal. That's it, and that's it for this laboratory. So I say this one.